Hello, this is Mr. Stansbury. I'm going to take you through some of the problems on the 2B assignment. Let's start with number 1 here. It says find A intersect B for the sets A and B. Okay, so we're going to find A intersect B and A union B. So A intersect B is what they have in common. So let's see, only 1 6. This one doesn't have a 7. It does have a 9. Does not have an 11, it doesn't have a 12. So the only ones that they have in common is just 9. Okay? A union B is everything that's mentioned in either of the sets. So I'm just going to start with just listing set A, 6, 7, 9, 11, 12, and then list all the other ones that are not listed over here, which is 5, 8, 10, and 13. Okay? All right, this one here, set A and set B. So A intersect B is everything that they have in common. They both have a 1. They both have a 3. They both have a 5. And they both have a 7. So 1, 3, 5, 7. Okay, and then a union B is going to be everything that's in either or. Since this 1, 3, 5, and 7 is also over here, I'm just going to just list off set B because that will cover everything. 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay? And just as a little side note, A, we could say that A is a subset of B, right? A is a subset of B. That's just kind of a little review from last year. But anyway. Okay, moving on here. Determine whether the sets are disjoint. Okay, so remember, disjoint means they have nothing in common. So that would, if A intersect B is the empty set, then that means they're disjoint. So 3... There's no 3, there's no 5, there's no 7, there's no 9. So A intersect B is the empty set. So therefore, it has to be disjoint. Okay? All right, number 3. We've got sets A, B, and C. Which pairs of sets is disjoint? Justify your answer. So it's going to be pretty useful to actually list off what A, B, and C are. So I'm going to just do that really quick. A, B, and C. Okay, so A, even numbers between 20 and 30. So between does not mean including. So it's going to start with 22, 24, 26, and 28. B is odd numbers between 20 and 30, so that's going to be 21, 23, 25, 27, and 29. And then C is composite numbers between 20 and 30, so those are non-prime numbers. So 21 is composite, 22 is, 23 is prime, 24 is composite, 25 is composite, 26 is composite, 27 is composite, 28 is composite, and I believe 29 is prime. Okay, so there's our sets, A, B, and C. Pretty important to have that info here. It's going to make these questions a lot easier. Which pair of sets is disjoint? So which do not have anything in common? So since this one is even numbers and this one's odd numbers, A and B are disjoint. Okay, because one has got even and one has got only even and one has got only odd. So there's no way that they could have any kind of overlap at all, right? Okay, there's no number between 20 and 30 that's both even and odd. All right, and then C, find N, the number of B union C. So let's see, we've got B union C. So anything that's in B or C. So we've got all of these, 1, 2, 3, 4, 5, 6, 7, plus any of these up here that don't show up. 8, because 23 is not in there, and 29 is not in there. 9, is that 10. I already lost track. 1, 2, 3, 4, 5, 6, 7, 8, 9. So that would give us 9 total elements in B union C. Okay, let's take a look at sum of number 4. Determine whether each statement is true or false. Explain your answers. If R and S are two non-empty sets, so that means that they actually have some kind of elements in them, and R intersect S is the empty set, then R and S are disjoint. That would be true for sure, right? Because it's just got, let's just say R has got 1 in it, the number 1, and let's say S has got the number 2 in it. Oops. They're not empty, and their intersection is the empty set, so R and S are disjoint. By this right here, this is really R intersect S is kind of the definition of disjoint, right? If they don't have anything in common, then that makes them disjoint. All right. Okay. Let's go with C. A intersect B equals A union B. Therefore, A has to equal B. That would also kind of make some sense, wouldn't it? Because if A intersect B, it's got all the same things as A union B, so the intersection is the same as the one that's in either or. That means they have to have the exact same things in both sets, so therefore A does have to equal B, right? There's no elements that are in only A or only in B, because then this would not be true. Okay. That's it for the selected problems there from 2B. If you have any further questions on any of these, please feel free to ask. Thanks.